Just yesterday, Meta released its Llama 2 LLM, and companies have already started implementing it. On your screen, you can see the implementation of Llama 2 LLM by A16Z Infra, and they have implemented this in a style. If you look at these examples, they are covering this Llama 2 implementation in a very nice way. And if you don't know, Meta has released this 13 billion parameter language model just yesterday, which is great and fine tuned for chat completions. It is free for research and commercial usage. Now, if you look at these examples, on the left hand side is an input, and on the right hand side we have output. In the input, you have to just set some parameter, and let me explain the parameters. Top underscore p means that it's a parameter which acts like a filter that controls how many different words or phrases the LLM considers when it is trying to predict the next word. If you set the top p value to say zero point 0.5, the language model will only consider the 50 most likely words or phrases that might come next. The default value is 1. Then we have max length. Max length is the maximum number of tokens to generate. And keep in mind that a word is generally 2 to 3 tokens. The default value is 500. Prompt is simply your text, and Llama 2 requires the prompt to be in this format, which is user and assistant. Then we have temperature. Temperature is a parameter of the model that governs the randomness of the responses. It is always a number between 0 and 1. A temperature of 0 means you almost always get the same response to a given prompt. A temperature of 1 means the responses can vary wildly. A good starting value is 0.75. Then we have repetition penalty. A repetition penalty is meant to avoid sentences that repeat themselves without anything really interesting. A positive penalty value implies reducing the probability of repetition, whereas larger values correspond to a stronger bias against repetition. So this is what these input parameters mean. And once you give them, you can see that in this example, we have asked this Llama 2 to write a poem about open source machine learning, and it has produced this fairly nicely written poem. Now, if you look at the second example, we are just asking it as a question about the self attention mechanism, and again it has produced a very well formatted answer. You can look at the other examples on this website, and I will drop the link in video's description. Not only you can play around with this example, you also have some demo here where you can also play around by just writing some prompt here. Maybe let me ask is what is capital of Tonga, and then let's see what it does. Just clicking on submit, and I'm keeping all the parameter as such, and this is perfect. I asked the same question from MPT7B in my previous video, and it was unable to determine that, but it has really come up nicely. Let me also ask it another question. Write me a smart contract in Haskell for Cardano blockchain. Let's see what it does now. Click on submit, and it has produced perfectly fine smart contract. Whereas MPT7B was unable to do so, it produced a smart contract in Solidity, which is not the Haskell language anyway. But this is great. As you can see, it is still generating it. So very nifty and quick LLM, I would say. And hats off to A16Z Intra and Replicate, by the way, who have done a fabulous job in implementing this in such a short period of time. And really, thanks to Meta for democratizing this LLM. I hope that you like this video. Please consider subscribing to the channel. Thank you very much.